So much for joining the webinar today, Decoding Thermal and Ignition Barrier Requirements for Sprayed Polyurethane Foam. Our presenter today is Rick Duncan, who is the Technical Director of the Sprayed Polyurethane Foam Alliance. We will be taking questions throughout, so just type them into the question field and Rick will get to them as possible. Whenever possible, and if we do not have time to answer all of the questions, we'll do our best to go back and connect with you after the webinar. We're going to have lots of folks participating today. We are also able to offer, SPFA is able to offer AIA credits for this content. So if you are an AIA member and want to get credit for this, if you would email me, I am Laurel Elam with ResNet, and my email address is Laurel, L-A-U-R-E-L, @resnet.us, and I can pass all that information along to Rick. One quick poll question before we get started is basically if you attended the previous webinar that we did. Let's see here, let me launch this question. Did you attend the previous webinar that we did a couple months ago about fire codes and spray foam insulation? So I'll give you guys a minute to participate in the poll. Okay, it looks like it's leveled out about 85% of the folks have voted, and it looks like most folks did not attend that webinar. So we have lots of questions, and this is sort of a follow-up to that. Okay. So I'll close that and let you get started. Thanks so much.
Good afternoon. My name is Rick Duncan. Yes, good afternoon. My name is Rick Duncan, and I'm a technical director with the Sprayed Polyurethane Foam Alliance, and first of all, I'd like to thank ResNet on behalf of SPFA for the opportunity to deliver this important presentation today. The presentation that I have, I will make this presentation available through Laurel or in ResNet. If you are interested, I will send this on to Laurel, so you'll get a copy of this. Just a couple things about who I am. I've been with the Sprayed Polyurethane Foam Alliance for over 4 years. Prior to that, I was the marketing manager for Honeywell's spray foam insulation business. And for 10 years prior to that, I was director of new product development for Saint-Gobain Insulation, managing their global programs for new materials and applications. And again, prior to that, I worked as in academia as a professor at Bucknell University. Just to confirm what Laurel said, this particular presentation has been approved by AIA, and you can get credit simply by contacting her, as she mentioned. The material that we have here is copyrighted. However, we want to try to distribute this information as widely as possible. So we'll make this presentation available, but if you do use any part of it or portion of it, we just ask that you contact SPFA. We'll grant you permission, but we just ask that you do mention and put a footnote that it is from SPFA. Just a little bit about the Sprayed Polyurethane Foam Alliance. We are a 501c3 corporation. We're a trade association representing the entire spray foam industry. We've been in operation for nearly 35 years under different names, but it's the same organization. We were early in the late 70s, we were the Urethane Foam Contractors Association. 87, we became the Polyurethane Foam Contractors Division of the Society for the Plastics Industry. In 99, that group became affiliated with the American Chemistry Council, and in 2003, we actually became the Sprayed Polyurethane Foam Alliance. And we're an independent trade association that represents spray foam contractors, manufacturers and distributors of polyurethane foam and other chemicals, as well as equipment, protective coatings, inspections, surface preparations, and other types of services. We have a strong relationship with the American Chemistry Council Center for the Polyurethanes Industry, CPI, and with the newly formed Spray Foam Coalition, which represents spray foam manufacturers. A little bit about what SPFA does. Well, we have an accreditation which will soon become a certification program in 2013 for contractors and suppliers and basically everyone in the value chain. We will be part of this program. We publish a number of technical guidelines, including one that I'll talk about today. We offer support of a technical helpline, which is given here. If you call that number, you'll get a hold of me in most cases. And we fund a number of different industry research programs. We also promote the idea of using spray foam by doing regulatory and legislative activities with building codes and other government organizations. We provide promotional and marketing tools for our contractors. We have a website at sprayfoam.org. And we also have an annual spray foam conference and exhibition. Usually it's in February of every year. And we provide an SPFA member directory and buyer's guide. So we do a number of things here for the industry. Today, what I'd like to do is I'd like to talk about a couple of topics. First of all, why do codes require thermal and ignition barriers? What they are, what defines a thermal barrier, where they're needed, what defines an ignition barrier, as well as where they're needed. I'll discuss some of the fire testing methods, both small-scale and large-scale methods, and also how you can inspect and verify that the particular product you're using has been installed properly and meets the model building codes. And then finally, I'll follow up with a couple of application examples that meet the current model building codes. Now, as I talk about the model building codes, I do have references throughout this presentation. They'll be in blue, which reference the appropriate sections of the code. Now, those reference numbers change, they're added, they're modified over time. So the numbers that I have in my presentation refer to the 2012 version of the I-codes. Let me answer the first question. Why do codes require ignition of thermal barriers? Well, spray foam is an organic material, and like all organic materials, it is combustible. Unprotected spray foam will ignite when exposed to fire. Maybe not immediately, but over a prolonged period with enough heat rate, it will ignite. Once it ignites, smoke and combustible gases can accumulate in the interior of the building, and during these fire conditions can lead to flashover, which is a serious event. In terms of spray foam used for construction, flame retardants are added to slow flame spread. They don't necessarily stop it. Again, it depends on the size of the fire in the building. And I also need to add that when flame spread is measured under controlled conditions like ASTM E84, it's not always representative of actual fire conditions. So that's one of the reasons why we have to go to some of the large-scale tests I'll talk about today. Now, why do codes require thermal ignition barriers? Well, about 35 years ago, when foam plastics were relatively new to the market, there was a lot of concern about fire safety. As a result, the three model codes that were in place at that time, they added their own chapters on foam plastics. And today, now that these three different codes have been unified under what we call the ICC model building codes, or the I codes, there are separate chapters dealing with the use and installation of foam plastics. Thermal and ignition barriers, what they're designed to do is basically to delay the combustion and ignition of foam plastics, including spray foam. They do not prevent it. They do not make spray foam a non-combustible material. However, this delay offers extra time needed for any occupant or workers to leave the building in the event of a fire, and it provides substantial amount of time, as you'll see in a video. Now, the requirements for foam plastics, including spray foam as well as board stock like expanded and extruded polystyrene and polyiso foam boards, they all fall under the same requirements in the building code under foam plastics. They're found in the International Building Code under Chapters 26, Section 2603, and this deals especially with fire safety. You will find almost identical language in IRC Chapter 3 in Section R316 of the 2009 and 12 codes. Due to renumbering, it used to be R314 of the 2006 IRC. But the language you'll find is almost identical. There are some nuances between the two codes, and I'll try to point those out as I go along. First of all, let's define what a thermal barrier is. what we call a 15-minute thermal barrier in particular, what it's designed to do is designed to separate foam plastics from all interior spaces with what we call an approved 15-minute thermal barrier. Now, next question is, well, what are these approved thermal barriers? Well, there are actually 3 different types of 15-minute thermal barriers, 3 different categories. The first one is a prescriptive thermal barrier. Probably the most common one we all are aware of is half-inch gypsum wallboard. As long as there's half-inch gypsum wallboard between the foam plastic and the interior space of the building, then you've met that prescriptive thermal barrier requirement. However, in some applications, drywall is not always wanted or preferred. So we have some provisions in the building code that allow for what we call an equivalent thermal barrier coating or covering. These particular equivalent thermal barrier coating or coverings allow these particular products to be used over all types of foam plastics. However, they must pass 2 large-scale fire tests. One is ASTM E119, which assures that the temperature rise on the outside of the wall when a fire is burning will not rise more than 250 degrees during a 15-minute fire exposure. In addition to that temperature rise test, it must remain in place after 15 minutes during a specified large-scale fire test, which I'll go over later in the presentation. Those are the first 2. There's also a third one that allows for special approval and alternate assemblies, and this is defined in both codes. You can have an alternate thermal barrier assembly, which can potentially include exposed spray foam or spray foam with protective covering or coating. This must comply with the performance criteria of specified large-scale fire tests. And there are 4 that we go through. It has to meet certain temperature release rate, temperature generation rate, heat release rates, and there's about 6 different criteria it has to meet for it to pass. However, it does not need to comply with the 15-minute increase in temperature for ASTM E119. So there are basically 3 ways you can define the thermal barrier. Now, in terms of the prescriptive thermal barrier, there are 2 recognized thermal barrier coverings, which need no testing. They are what we call prescriptive thermal barriers. Traditionally, it's been half-inch gypsum board, and this is the prescriptive coating that's very popular over walls and ceilings. I should point out that many times if you have ceiling systems that are not half-inch gypsum board, they are not prescriptive thermal ignition barriers. Prescriptive thermal barriers. In addition to that, most recently in 2012, half-inch wood structural panels was added only when used on the floor. So if you have a floor construction only, you can spray foam underneath that floor, provided that it's a half-inch thick or greater, wood structural panels, such as plywood subfloor. But again, that only applies to floors. A half-inch wood structural panel is not considered a 15-minute thermal barrier on walls and ceilings. So in addition to that, as I mentioned earlier, anything that's not one of these 2 prescriptive or equivalent thermal barriers, they must be approved by large-scale fire testing. So equivalent thermal barriers, as mentioned earlier, it must have a 15-minute performance in the temperature transmission test, ASTM E119, and the fire integrity test, which is a room corner burn test, which there are 4 different alternatives that you can use, and they are listed there: NFPA 286, UL 1715, UL 1040, or FM 4880. As an alternative for that, you can also pass NFPA 275, which includes NFPA 286 and ASTM E119. So these are the ways that you can come up with an equivalent thermal barrier. Finally, alternative assemblies, thermal barrier assemblies, these are product-specific assemblies that must be tested. And when you have an alternative assembly, which may include a specific brand of thermal barrier coating with a specific brand of spray foam or other foam insulation, the test must be done on those specific brands. It must be done in the assembly that you want to have approved, And for example, most cases we use a protective covering to aid in this test. And these protective coverings, they can include cementitious coatings, fibrous coatings in some cases, and other proprietary products such as intumescent coatings. Now, one of the things that's often confusing is that while we did say earlier that thermal barriers are required to separate the interior space from the foam plastic, they are not always required in every case. And there are specific cases in the code where thermal barriers are not required. First of all, if you put foam inside of masonry or concrete walls, and we see this done often with cinder block and CMU blocks, you don't need to have a thermal barrier because the block itself is sufficient. Similarly, when we install foam in cooler and freezer walls where there's less than 400 square foot of floor space, you don't need a thermal or ignition, a 50-minute thermal barrier. Laminated metal wall panels for one-story buildings are exempt. Similarly, if you use spray foam on the top or on the outside surface of a roof, which is typically a low-slope roof, you do not need a thermal barrier over the foam, provided that it passes another fire test, UL 1256. Also, when you see foam plastics being used inside of entry doors or inside of garage doors or behind siding as a backer board, they too are exempt from a thermal barrier requirement. Again, most of these have metal casings, or in the case of siding, they're used on the exterior of the building. However, there are some specific places inside of the building where thermal barriers are not required. I think the first place that's most important, especially to weatherization professionals, is when we use foam on sill plates and headers. And here's, of course, a classic example of where we want to use a small amount of foam to air seal the cracks and gaps that we traditionally find at the union between a foundation and a framed building. However, there are specific limitations to not covering this type of installation with the thermal barrier. First of all, it's limited type 5 construction, which is basically wood frame and in most cases residential types of construction, or wood frame multifamily. So you want to be sure that the building that you're doing this in is a type 5 building. There are also maximum thickness limitations for the foam. 3 1/4 inches is what the code says, regardless of whether it's an open cell or a closed cell foam. Another requirement is that it also has to be a Class A foam for both low and medium density foams. Open and closed cell foams have to be Class A, which means that it has to have an ASTM E84 test that shows that the flame spread is less than 25 and the smoke developed is less than 450. There are some other places where thermal barriers are not required directly in contact with the foam. And this is where we get into certain attics and crawl spaces. Again, these are targets, areas that are easy access for weatherization contractors and are great candidates for using spray foam. Now, there are certain, when we say certain attics and crawl spaces, there are limitations on the attics and crawl spaces where thermal barriers are not needed in contact with the foam. First one is where entry is made only for the service of utilities. So if there is utilities up there and typically the occupant is not going up there, maybe someone goes up there once a year to do an inspection or service a piece of HVAC equipment, you are not required to have a thermal barrier over the foam. And that's the language of the IBC. There is very similar language, but not exactly the same, in the IRC, and they say where entry is made for repairs and maintenance. But it's essentially the same, but not exactly. But that's what it says in the code. You do not need thermal barriers in these certain types of attics or crawl spaces. Another very important requirement is that in these attics and crawl spaces, no storage is permitted. And I know many people often sell the benefits of using spray foam, for example, under a roof deck to create an unvented attic. However, if that foam does not have a thermal barrier coating or covering on the foam itself, you cannot use that attic for storage. Another provision here is that when you do go with these types of attics and crawl spaces, you need to have an ignition barrier separating the foam from the interior of these attics and crawl spaces. And I'm going to define what that ignition barrier is in just a few moments. But I want to also make sure that it's understood that even if you have these certain attics and crawl spaces, you must have a thermal barrier between these attics and crawl spaces and the occupied space above. Again, these attics and crawl spaces, the criteria is defined in the code. It's not always easy to define in practice. I always suggest if you have a question is to consult your local building official. They can give you a judgment on this. But generally where you have a small attic hatch, no floor in the attic, and the hatch requires that you use a ladder, and there's no storage up there, generally that would apply as one of these types of limited access attics and crawls. Now, as I mentioned in the previous slide, we talked about this other type of barrier called an ignition barrier. This is also a fire protective covering that you can use instead of the 15-minute thermal barrier in limited access attics and crawl spaces. The ignition barrier itself, in general, will not provide the same degree of fire protection as a 15-minute thermal barrier. In the building code, there are, depending on which code you use, there are 6 or 7 prescriptive ignition barriers. They're listed right here. You see it's 1.5 inches of mineral fiber insulation, which includes fiberglass. And most of the time this is a sprayed-on fiberglass that adheres to the foam itself. A 1/4-inch wood structural panel, so you can use 1/4-inch plywood. You can use 3/8-inch thick particle board, 1/4-inch thick hardboard, 3/8 thick gypsum board, and corrosion-resistant steel of a certain thickness. Also, recently added in 2012 in the IRC only, for attics only, you can use 1.5 inches of cellulose insulation directly to the foam. Now, as you see in this list, you can see that most of these products are in the form of panels, and you can only imagine how much difficulty you would have installing these panels over the foam if you have a trussed attic or difficult to access attic. So for that reason, the code allows what we call alternative ignition barrier assemblies by special approval testing. And that's what I have in blue, and that's what we'll talk about next. There are special approval tests for these alternative ignition barrier assemblies that are provided there in both versions of the building code. Now, you can have 2 alternatives when you go through and do this test. The first one says you can use the same 4 large-scale corner burn test as you use for a thermal barrier. Okay, so you can go and do an FP 286, UL 1715, FM 4880, or UL 1040. Perhaps with the exception of one foam that I know of, almost no, one spray foam that I know of, very, very few spray foams will pass this 15-minute test, or in other words, will pass as a 15-minute thermal barrier. The degree of the heat given off in that type of test, the amount of flame, is too severe for most foam plastics to withstand. So aside from that, you also have the opportunity to use a special end-use fire test. So in a couple of years ago, the spray foam industry worked with ICCES to develop what's called an Appendix X test. This Appendix X test is described in the acceptance criteria for spray polyurethane foam. It's ICCES acceptance criteria AC 377, and it can be used to qualify spray foam for spray foam ignition barrier systems for use in crawl spaces and under roof decks, as the fact we described before. And what it does, it provides an equivalent performance to 1/4-inch plywood. Remember, 1/4-inch plywood was one of the prescriptive ignition barriers. This test was developed to show that the foam, or the foam with a coating, will be equivalent to foam covered with 1/4-inch plywood. More recently, we've also seen, and this again is for using foam under a roof deck or on the walls of a crawl space or underneath a crawl space. However, we also see that foam can also be applied on the floor of the attic. On the floor of the attic, the foam is not subject to the same type of heat intensity that you would on a wall or ceiling. So we needed to have a test to qualify foam ignition barriers when foam is applied to the floor. So in 2011, we developed, or actually worked, and have approved the use of ASTM E970, which is a radiant heat flux test used for cellulose. So that is now included as an allowable test for use of spray foam on an attic floor. Now, I should also add that there are some additional fire safety requirements for certain types of commercial building construction. And these are listed in the IBC alone in section 2603.5. And these are for type 1 through 4 construction, which is basically everything but wood frame. So we need to be cognizant that there are additional fire test requirements. They are listed here. As you can see, you still have to have a thermal barrier. The product has to be labeled. It has to go through an NFPA 286 test as installed. It has to be Class A. Those are pretty relatively low hurdles for most spray foam. However, the big one is getting past NFPA 285. And that's a large-scale fire test that really needs to be done literally for each wall assembly that's used. Now, some manufacturers have done this, and they've gotten engineering judgment to approve their test data for less severe wall assemblies. But I should note that if you're, again, using spray foam in certain commercial buildings, you may want to be sure that you're in compliance with 2603.5. But again, if most folks in this audience, I understand, are doing residential, you won't need to meet these specific requirements. Now, let's talk about this fire testing. As I mentioned earlier, there are some small-scale tests and some large-scale tests. And there are actually 3 categories of fire tests that we use for foam plastics. The first types are surface burning characteristics, and these are sort of material level, also called small-scale fire tests. The next type is room tests, where we look at the fire performance of spray foam installed in an actual assembly. And then there are structural integrity tests, where we look at when we build an assembly with foam, and we make sure that it can withstand structural loads in addition to fire. These testing standards are all well defined. They're either they're monitored and developed by ASTM, Underwriters Laboratories, National Fire Protection Association, or Factory Mutual. So these are all standards that are well understood. So the first type of test that spray foam has to, for construction purposes, has to follow is ASTM E84. It's also known as UL 723. It's the same test. It's known as the Steiner tunnel test. This tunnel test has been around for 60 or 70 years, and it's a basic requirement for almost all interior building products that it passes this test. In this type of test, and I'll show a picture of this in a moment, the material is suspended on the top of a tunnel ceiling, and it's ignited by a gas burner at one end, and two primary measurements are done. The speed of the flame front moving across that material is measured, and that is used to calculate the flame spread index, or the FSI, for the material. And at the same time, the smoke density from this material burning is measured at the outlet, and that is used to determine the smoke developed index for the material. As a reference material, there are 2 baselines. The FSI and the SDI, the flame spread and smoke developed for a fiber cement material, basically a non-combustible material, is 0 and 0. For red oak put into that chamber, the flame spread is 100 and the smoke developed is 100. So you can use these numbers to kind of get a relative idea of how the particular material performs relative to red oak. We need to caution that this is a scale test, and it cannot be used to make any judgment of how a building product will perform in a real fire. In addition to that, spray foam is also using ASTM E970, the critical radiant heat flux test, and used to qualify combustible installations on the attic, or including cellulose. And what this small test is, it says that the flame should not progress more than 1 meter under a heat flux above that floor of 0.12 watts per square meter from an overhead gas burner. Again, these surface burning tests are used for comparative purposes only and not suitable for relating to real-world fire conditions. To give you an idea, the ASTM E84 tunnel, if you haven't seen one, it's 25 feet long and has a 2-foot by 2-foot cross-section. Here's sort of a cross-sectional view. You see fire brick on 3 sides, and the material itself is suspended from the top. Here's an actual view of the 25-foot long chamber. At one end here, we measure the exhaust. At the other end, we ignite the flame, and we watch that flame burn along the length of the chamber. The picture of the ASTM E970, the critical radiant heat flux test apparatus. You put a 1 meter specimen in here. There is a gas burner giving off a certain radiant heat from this, and if this product does not ignite and burn through the entire 1 meter length, then it's judged to pass that test. And what I also should note that back here on this ASTM E84, there is a 4-inch material thickness limitation. So this particular test, you can only put 4 inches of material from the ceiling of that chamber. In this chamber, there is really no practical material thickness limitation. This bed here can be raised and lowered so that it's the standard distance above that burner to give you that heat, the amount of heat flux applied to the surface of the material. And here, actually, we've shown this with foam plastics. Here's a closed-cell foam of different thicknesses, and we can see that we get some pretty consistent results from this test regardless of the thickness of the foam. Now, we talked about the surface burning requirements. In the code, it specifically lists that spray foam used for insulation must be a Class B type of spray foam. It must have a flame spread index of less than or equal to 75 and a smoke developed index of less than or equal to 450. Now, there's also a Class A, which is an optional requirement, and I should add that this is achieved by most spray foams today, and it may be mandatory in certain applications. Remember earlier we said that you could use spray foam in band joists. However, that must be a Class A foam. And a Class A foam is one that has a lowered flame spread index, which is now lowered to 75, but a smoke development index of 450. And then finally, there is a different requirement for spray foam used on low-slope roofs. It must have a flame spread of less than 75, but because it's used as an exterior product, there is not so much of a concern about the smoke development. There's no occupants on the roof, so there is no limit on smoke development. However, this roof assembly must also pass a particular test for roofing foam. It's FM 4450 or UL 1256, as I mentioned earlier. What I also want to be sure of is that in terms of fire resistance, you do not want to use a roofing foam on the interior of a building. It is not treated with the same fire retardants and may not meet the Class A or Class B performance. There are other reasons why you generally don't use roofing foams. They don't spray as well, and they provide some different characteristics, but you want to be careful that you never use a roofing foam inside of a building for this reason. Now, one of the things that we often see is that, and remember getting back to that Steiner tunnel test or ASTM E84, we see that the surface burning test is limited to 4 inches of material thickness. Right now, in the code, there is some additional testing required for foam plastics to be installed at greater than 4 inches. Now, right now the surface burning requirements for foam plastics greater than 4 inches, special approval testing is permitted. Now, traditionally, to allow foam to be at a thickness greater than 4 inches, most of our suppliers, or nearly all suppliers that have foam rated at 4 inches, have done one of the large scale room corner fire tests. And this has been repeatedly done for a lot of foam products over the past 5 to 10 years. They all use a 1/2-inch gypsum wallboard between the foam and the fire source. and this has been used to determine the maximum foam thickness intended for use. Well, if you look at this type of particular testing we've been doing, the half-inch gypsum is already a 15-minute thermal barrier. And what we found is that none of these particular assemblies using foam have failed, as long as they pass the E84 test at 4 inches or less. None of these have failed. In fact, we've done these at a wide variety of thicknesses of foam, and the thickness of the foam, once you're beyond 4 inches, also doesn't seem to affect the test. So in many cases, we see that it's a redundant test. All it's really proving is that half-inch gypsum is a good 15-minute thermal barrier. So there's been a proposal to actually remove this requirement from AC 377. That's under consideration right now. Now, for room corner fire testing, this is required for a thermal barrier requirement. Now we get into these full-scale tests, and these are used to test for ultimate thermal barrier materials or ultimate thermal barrier assemblies. The 4 tests that are used, as mentioned earlier, are NFPA 286, UL 1715, SM 4880, and UL 1040. They're all relatively similar. I'm going to show an example of NFPA 286. Also with NFPA 286, it requires that this test, in the building code, there are specific requirements on heat release and temperature and smoke that are required from this test. It's listed in the section 803 of the IBC and 315.4 of the 803.2 of the IBC and section R315.4 of the IRC. Now, if you want to have your product qualified as an equivalent thermal barrier, it has to pass one of those 4 tests above, plus it has to go through this ASTM E119 or UL, I should say UL 263, not U263, time temperature curve. Now, what is a room corner test? Well, the room corner test procedure is basically a fire test on a room that's constructed using the typical wall and the ceiling assemblies. A fire source is placed in the corner of the room, and it's usually a wood crib of some specified wood and specified construction, or more recently, I think the preference now is to use a gas burner because that's a lot more controllable in terms of the heat release from the fire. And this fire source is ignited, and during a period of time, we measure certain things like heat release rate from the room, the temperatures at the ceiling of the room, the heat flux measured at the ceiling of the room. Some call partition. This is where we actually roll up newspapers and we put it on the floor, and when those newspapers get hot enough, they'll ignite. And then finally, a very easy visual test, which is something flame over. And again, you'll see this in the video that we have of a fire test. Here's a quick diagram of what a room corner fire test looked like. In a PA test, the room is 12 foot deep, 8 foot wide, and 8 foot high. And in one of the 2 back corners, we put a wood crib or a gas burner. In the NFPA 286 case, it's a gas burner, and we ignite it, and we run these tests. Here are a number of different assemblies that SPFA tested when we developed Appendix X. What this laboratory test looks like, here's sort of the cross-section of the room with the fire in the corner. Just outside the door, there's a huge hood which collects the smoke. In the ceiling, there are thermocouples that measure the ceiling temperature and the heat flux. We put paper on the floor of this room to look for target ignition, and we also watch for a flame over, which is a deadly condition, which then where you see the flames coming out the door. This is all pretty serious instrumented test. It's done in a few labs across the U.S. When we do our testing for foam, we use typically wood frame construction, but we don't use 2x4s. Typically in the ceiling, they're often 2x10s or 2x12s because we want to do our testing with the thickest possible foam to get approvals. The walls are typically 2x8s, again, to get an adequate approval thickness. And then in some cases, you may test your coating applied to the foam, or in this case, here's a picture of when we did our baseline testing for the 1/4-inch plywood ignition barrier. This gives you an idea of what these tests look like. When the fire is ignited, typically in the NFPA 286 test, that fire is ignited 40 kilowatt intensity for the first 5 minutes, and then in the remaining 10 minutes, the fire is boosted up to 160 kilowatts, and that room survives, meeting a number of different requirements, then it meets the 15-minute criteria. If it does not, then you don't have a 15-minute assembly. So this is, again, showing the progression of a fire. It'll go up the corner of the room, it'll ignite the ceiling, and eventually you'll get flame over in the room. So now I guess this is the good part. I'm going to try to show you an example of a fire test that was done on a spray foam product with and without an intumescent coating. And this is actually an NFPA 286 test. It's a modified one. It's set up the same way as a standard NFPA 286. The only difference is that when we did this a number of years ago, we showed that a piece of plywood over, quarter-inch plywood over spray foam will flame out in about 4 minutes and 18 seconds. So that was the baseline for which we did testing on what we call the ignition barrier coatings that are used over foam. So this is a test of a foam product with an actual ignition barrier coating. And you see here that there is a timer that this guy's standing in front of right now. He's going to move away from it in a minute, but it's an approximate timer. Now we're about 15 seconds into this test. And you can see that the foam, and here's our gas burner, and the foam is burning at a pretty stable rate. And this will occur actually with an intumescent coating. It's going to occur and last for a number of minutes. I'm not going to go through the whole 4 minutes and 18 seconds. I'll give you a quick snapshot here. You see we're about 2 minutes into the test, and really nothing is happening. We see some smoke in the room, but really no flame spread. So we move ahead a little bit. We see in about 4 minutes, nothing happening. And we'll see soon here in about 4 minutes and 18 seconds, again, nothing happens. Here we are, 4 minutes and 18 seconds. This particular coating passes for for an ignition barrier coating. Right now, it passed 418. So now what this particular test, they're going to actually move this test forward at 5 minutes. They're going to increase it up to 160 kilowatts. The intumescent coating, ignition barrier, will not withstand that. But the idea is that this lasts for 4 minutes. Here, I'm moving this ahead a little bit. You see that when they increase this to 160 kilowatts, the ignition barrier coating will not survive. And you'll see that in a few minutes, a few seconds, you'll get flame out. Now, that's actually a good test that's used to qualify an ignition barrier over foam. And you can see that in the case of a 40 kilowatt fire, which is about the size of a trash can placed in the corner of that room, that particular assembly will last a sufficient amount of time. I'm also going to show you what happens when you don't have an intumescent coating on the foam. Here again, this is the identical test without an intumescent ignition barrier coating for a particular foam. So you see the testing has started. The guy will move out of the way of the clock in just a moment. And watch the second hand here, because I'm not even going to move this test forward. We're about 10 minutes into the test. We're about 20 seconds into the test. You see that smoke and the fire is moving up the corner of that wall. And you see the flame cloud that's developing inside of that room, and in just about 3 seconds, it's going to come out of that room. That's flame over. This test is over. And what that means, there's an example of a foam that without an ignition barrier coating, you can see that it will not last 35 seconds. When we were doing this testing, in fact, I've seen foam with ignition barrier coatings last not just 4 minutes and 18 seconds with a 40 kilowatt flame. I've actually seen the foam last 20 minutes with the same 40 kilowatt flame and the fire not progress. So I guess the idea here is very important to realize that even if the building codes are not applicable in your jurisdiction, especially on a remodeling project or a retrofit project, always important to use the ignition barrier system recommended by the foam manufacturer. And these foam manufacturers have done this test, and from this test they can determine whether or not an ignition barrier coating is needed in attics and crawl spaces. Now, a little bit about inspection and verification, then I'll get into a couple of examples and I'll wrap up the presentation. These alternative fire assembly test results, they must be done by a third-party accredited lab. But if you get the test data themselves, that can be difficult to interpret. What most foam suppliers do is they go and they have an evaluation report that's developed. Again, an evaluation provider will take these fire test reports from an accredited third-party lab. They'll independently evaluate them, and the provider will write a report which defines specific installation requirements that allow that foam to be used with or without an ignition barrier in attics and crawl spaces. They'll identify the product and its performance. They'll identify the maximum thickness for that foam, and they will identify whether alternative ignition barrier assemblies, if any, are needed. A majority of spray foam insulation products have what we call evaluation reports. Many of these evaluation reports are actually evaluation service reports, which are developed by the ICC Evaluation Services, or ICCES. You can find these on their website, or you can find them from the foam manufacturer's website. They use an acceptance criteria AC377, which includes Appendix X for testing ignition barrier coverings. Now, this eliminates the need for contractors and inspectors to try to interpret test data. It really simplifies things. These evaluation reports will say which version of the code the particular product is compliant with. And it also defines product-specific requirements for thermal and ignition barriers based on these independent tests. Just to give you a sample of what one of these looks like, here is an evaluation service report for a foam. You always see which versions of the building code evaluation report is applicable to. If you go down further in the other parts of the evaluation report, it'll tell you when and where a thermal barrier is required, when you need a prescriptive ignition barrier in an attic or crawl space, and when you don't need a prescriptive ignition barrier in an attic or crawl space. This one particular foam allows you to put an intumescent coating on it, and it describes the particular type of coating that must be used and how thick it must be applied. So you can find all this information in an independent format from one of these evaluation reports. So finally, I'll wrap up with a couple of applications and then I'll entertain some questions. When we get into weatherization, we often see the use of spray foam under a roof deck. And if you have spray foam under a roof deck, and that's where we see a lot of benefit for our products, especially when we have ductwork and HVAC equipment in the attic, you can do this with one of these approved ignition barriers, or in some cases, some foams pass the Appendix X test without an ignition barrier coating, and those foams can be used without any coatings in these limited access unvented attics. Same way, those foams can also be used without a coating if they pass Appendix X, or with an intumescent coating on the foam that's passed Appendix X in limited access unvented crawl spaces. Again, the requirements there are no storage. However, we also need to reinforce the idea that between these attics and crawl spaces, you must have a 15-minute thermal barrier. And this, you'll get this by having half-inch gypsum or a half-inch structural panel on the floor. And of course, the walls themselves, if you have spray foam, you'll meet this with your half-inch gypsum board. Now, when we go into this type of application, we know that homeowners, if the attic is easy to get to, they want to put stuff up there. They want to put up their holiday decorations, old photos and everything, and that's always tempting to do, especially in a spray foamed attic, because now you've got a nice conditioned space instead of a space that's very hot or very cold in the summer and winter. So if you want to actually allow storage in this attic and you have easy access, it's important to know that you have to have a 15-minute thermal barrier over the foam separating the foam from this attic or this accessible crawl space that's used for storage. In addition to that, if you have a ceiling in your home that is not a 15-minute thermal barrier, in other words, it's not half-inch gypsum, if it's a ceiling tile ceiling, that is not generally a 15-minute thermal barrier separating the occupied space from the foam. So in that case as well, you will need a 15-minute thermal barrier over the foam. So sometimes I see applications where you want to put foam on the attic floor. And it's actually a great idea for weatherization, especially if you don't have any ductwork or HVAC equipment in the attic. In many cases, it's not economical to put foam underneath the roof deck if you don't have ductwork and HVAC equipment there. So in many cases, we will see foam being applied to the attic floor. And again, you have to have half-inch gypsum between the foam and the interior space of the building. And when you have this limited access space above, you still need to have an approved ignition barrier or a foam that's been approved to Appendix X without a coating as an ignition barrier per ASTM 970. So you can get away with not putting, and generally what we're finding, almost all foams will pass ASTM E970 without any additional incandescent coating or ignition barrier coating. So that's what we have for residential. Here's another particular case where we see foam being used. And this is sort of a special case, but we see this a lot in rooms over garages or in Cape Cod-style homes where we have an interior space on the second floor. And we have a collar tie here, and there's a very limited space. If that space, if there's no access to that space, in other words, there's no attic hatch, it's completely concealed, you don't need to put any type of ignition or thermal barrier over the foam in those cases. Similarly, if you have foam underneath the roof deck behind a knee wall, there is no need for foam to have an ignition or thermal barrier on the foam if there is no access to these areas. Another question we get is space under low-slope roofs. This is typically, you see this in commercial buildings. If you have a plenum area, which can be used for air return in that area, and you have a suspended tile ceiling, remember that suspended tile ceiling is not generally your 15-minute thermal barrier, so you have to coat that foam with a 15-minute thermal barrier or use a foam that's approved without a specific covering. Now, again, not many foams. There's only one that I know of that may do that. So check with the manufacturer on that. Again, you still have to have your 15-minute thermal barrier on your walls. Another option you can do with the new version of the, and I should say of the IBC, and I wrote the IRC with the IBC. Again, I need to change that. I wrote IRC in blue. That should be IBC. My mistake on that. I just updated to 2012 today. Is that if you have a plenum here, it must meet a ASTM 84 2550 per ASTM 84, and also basically must be a 15-minute thermal barrier assembly, which is what this says here. This is very difficult for a foam to do, especially the 2550. It's definitely a requirement if you're going to use this as a return air plenum. If you're going to, also another option for using this as a return air plenum is you can completely line that plenum area with a sheet metal ignition barrier. Again, only sheet metal ignition barriers. You can't do this with wood or drywall or any of the other prescriptive ignition barriers. There's only one ignition barrier that you can use for a return air plenum. I would finally like to make the comment here that any prescriptive ignition barrier or approved alternative ignition barrier assembly can be used in this area above a gypsum board ceiling if it is not used as a return air plenum. In other words, if that's just dead airspace, which you will probably find in a lot of residential low-slope roof buildings, then you only need to use an equivalent ignition barrier over the foam, or with some foams, no ignition barrier at all if they've been tested. So, and I'm going to close with a couple of final comments and open it up to questions. A couple of things about thermal barriers and spray foams. All spray foams require a thermal barrier between the foam and all interior spaces. However, there are some exceptions. I went over those earlier. band joists, certain addicts, and the like, and we covered those. If an uncovered foam can actually pass a 15-minute thermal barrier test or meets the acceptance criteria of these large-scale corner tests, no thermal barrier or coating or covering is needed over the foam. Again, I've only heard of one foam that's reported to have passed a UL 1715 test, either for a vertical application or for a horizontal application without a 15-minute thermal barrier covering or coating. There's only one. This foam has some special additives in it, but for the most part, generally speaking, very few spray polyurethane foams will pass without a thermal barrier. As for ignition barriers, I can probably make some general comments here. Most closed-cell foams do not require an ignition barrier coatings or coverings in these limited access addicts and crawl spaces. Most of closed-cell foams have actually passed the Appendix X test, which means that it lasts 4 minutes and 18 seconds with a 40 kilowatt burner fire, which makes it equivalent to foam with 1/4-inch plywood over it. It passed without any additional covering. The same test has been performed on open cell foams, and what we found out initially in 2009 and 2010 is that most open cell foams did require an initial ignition barrier or thermal barrier covering to pass Appendix X. However, the technology is changing. We've seen some innovation since 2009, and within the past year, we've actually seen that there are 3 open cell foams that have modified their formulations that allow them to be installed in limited access addicts and crawl spaces without ignition barrier coating. It's always important, however, to consult your evaluation report or third-party fire test reports to confirm what the ignition barrier requirements are for each brand of spray foam product that you're using. And finally, it's very important to confirm that ignition barrier requirements are permitted by the local code official. In summary, I think I've covered all these topics, and I'd like to open this up to questions. And I guess, Laurel, at this time, we have a number of different questions that have been typed in. I'm going to try to get to all of them. Let's see.
Okay, great.
How do you want me to handle this, Laurel? Do you just want me to go through the first couple of questions that were asked and
sure.
Kind of go through those? And
sure.
How much time do we have here to do this? I know that we're getting close to the top of the hour here, and I don't want to cut off.
I say let's try to do what we can in the next 5 or so minutes. That way we're not wrapping up too much past the hour. But if there's a couple questions that weren't addressed that you see on that list, if you just want to go ahead and address them.
Okay, and also you'll give me this list, and I can try to provide written answers to all of these.
Absolutely.
Okay.
Yep.
So I'm going to try to open this up and questions. Okay, I'm not seeing this completely here. I'm struggling here a little bit.
You can kind of pull it out of that dashboard on the side.
Oh, okay, I see it here. Okay.
And then you can view the text better that way.
Okay. Okay. I think I see it. That's better. Okay. All right. So the first question I see here is, must the ignition barrier be in contact with the spray foam? Yes, it needs to be in close contact with the spray foam. Again, we saw the prescriptive ignition barriers that were listed. They're all panelized products. You can't get them in perfect contact, but they must be installed as close as possible to the particular foam. For spray foam, we very rarely see those panelized products being used. It's almost always an alternative ignition barrier coating. They're almost always, in most cases, I should say, they're either intumescent coatings or fibrous insulations. So they are almost by default in contact with the foam. Okay. Okay, we've got a couple of requests for the presentations. And here's another question here. Are spray foam products manufactured and available that are adequate as ignition barriers by themselves without an additional second pass? Yes, and I think I may have answered that in the last slide. Most closed cell foams do not need an additional ignition barrier coating. Most open cell foams, right now they still do, but there are new products that are evolving, open cell products that do not. Okay, the question here, does a 15-minute thermal, or oops, I see that one disappeared. Okay, here it is. Does a 15-minute thermal barrier consist of half-inch drywall? Does the drywall need to be taped? Actually, that's an excellent question, and it's my understanding that it does. But that's a question that we haven't looked at. By default, almost all in when we install drywall in most interior applications, we tape and finish it. But that's actually a very good question if it needs to be taped, because obviously there is a considerable cost for taping and finishing drywall. I've seen that typically on the order of half the cost of drywall is involved in taping and sanding and taping and refinishing. There's a lot involved there. So that's a good question. I will check on it. That's a very good question. But I will get back to you on that one. Do codes require intumescent paints to be listed and have inspections of manufacturers' plants for quality control? I'm not aware of that. In terms of spray foam for intumescent paints, they need to be tested with foam. For certain types of intumescent paints, there are acceptance criteria that that are developed that would ultimately require that when you have these foams manufactured, they would require a certain type of quality control and regular plant inspections. Okay, let's see. Okay, let's see, let me get, how can a paint coating, let me get to this next one here, scroll down a little bit. How can a paint or coating pass the thermal barrier test when it does not pass, now these are moving on me, but it does not pass ASTM E119 test? And that actually, if a coating is used and can pass the 15-minute thermal barrier test but not the E119 test, then what you actually have is you have an alternative thermal barrier assembly. Okay, and it must be a specific product, and it puts some limitations on that type of coating. When you have an equivalent thermal barrier which passes both the 119 and the room corner test, then that particular product can be used on any foam. So it does set some limitations on that, product-specific limitations on that coating. That's why you see there are a couple of thermal barrier coatings that have done this test, but they've done that test repeatedly on a wide range of foams. So those are good as what we call alternative thermal barrier coatings. Okay, I guess I have time for one more to meet the 5-minute requirement. In an ignition barrier required on an attic knee wall? Again, if that knee wall and the spray foam is applied to the back of that knee wall and that behind that knee wall is inaccessible, in other words, there will be no one going in there for any service of utilities, completely blocked off, then no, an ignition barrier is not required. However, if there's a doorway into that knee wall, and you may have occasional inspections back there, and workers can get back in there, yes, an ignition barrier is required, or a foam product that does not require an ignition barrier for Appendix X. It is required in those types of spaces behind knee walls. So, Laurel, I think I've hit my 5-minute limit. There are a number of questions. I will try to take these and answer these individually, and then you can distribute them to the audience. But I think our time is done here. So.
Absolutely. Thank you so much, Rick. This webinar was excellent. Thanks to all for your participation. Just like Rick said, we're going to be able to follow up with the questions that we were not able to answer on the call today. I have recorded the webinar. There are several different questions that came in about getting the webinar, and as soon as I have the file converted, I will send it out to actually everyone that signed up for the webinar, not just the participants today. So I thank you for your time, and I wish you a wonderful weekend.
Okay, thank you.
Bye-bye.
Bye now.